You thought you knew what a comet looked like. Dirty snowballs from the edge of our solar system, water-rich and predictable. But on July 1st, 2025, a 20-inch telescope in Chile's Rio Hurtado Valley spotted something that breaks every rule. 3I Atlas. Not just another visitor, an interstellar wanderer with chemistry that should not exist. Red dust turning green, carbon dioxide where water should be. Industrial signatures bleeding into space. What happens when a comet carries the fingerprint of technology? Why does its spectrum scream impossible? And what does that tell us about what lurks between the stars? Atlas found it first. The Asteroid Terrestrial Impact Last Alert System. 4 telescopes scanning for rocks that might kill us. But 3. Atlas was moving wrong. Too fast. 61 kilometers per second. Hyperbolic trajectory with an eccentricity of 6.141. No solar system object moves like that. By July 2nd, the math was clear. This was the 3rd confirmed interstellar visitor to our neighborhood. 1 Oumuamua in 2017, 2 Borisov in 2019, now 3 Atlas, blazing inbound from the constellation Sagittarius, somewhere near the galactic center. If you value documented space discoveries like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from the R-Cursive preprint server's latest papers, including Tony Santana Rose and colleagues August 2025, study and paper 25.08.00808, and Martin Cordner's James Webb Space Telescope findings in paper 25.08.18209. Sources that dive deep into spectral analysis most documentaries won't touch. Now back to the information. 4.5 AU out when discovered. Already glowing. Already wrong. Most comets need to get close to start out gassing. 3. Atlas was active when it should have been a frozen rock. David Jewett at UCLA confirmed it. July 2nd, using the Nordic Optical Telescope. Clear cometary signature, diffuse coma. But here's where normal ends. The spectrum showed red, deep, saturated red like dried blood. Early July images from multiple observatories painted the same picture. Tidy Observatory's 2-meter twin telescope, the Very Large Telescope, even ground-based amateurs could see it. Reddish dust grains several micrometers across, similar to D-type asteroids in outer solar system objects. Normal enough, until it started changing. Tony Santana Rose from the University of Alicante led a team tracking 3I Atlas from July 2nd through July 29th. 16.1 6-hour rotation period, 0.3 magnitude brightness variation, and something unprecedented, progressive reddening throughout July. The object was evolving in real time, surface composition shifting, activity ramping up. But this was just the beginning. August 6th, 2025. The James Webb Space Telescope aimed its near-infrared spectrograph at 3I Atlas, 3.32 AU from the Sun, still farther out than Mars. What Webb found changed everything. The coma wasn't water-dominated like every comet we'd ever studied. It was carbon dioxide, 95% CO2, 5% everything else. Martin Cordner at NASA Goddard called it among the highest CO2 to water ratios ever seen in any comet. 129 kilograms per second of carbon dioxide streaming off the nucleus. 6.6 kilograms per second of water. 14 kilograms per second of carbon monoxide. Less than half a kilogram of carbonyl sulfide. The chemistry made no sense. Comets form in the cold outer regions of star systems where water ice dominates. CO2 should be the minor component. Here, the roles were flipped. 2 theories emerged. First, 3. Atlas formed near the CO2 ice line of its parent star, where carbon dioxide freezes more readily than water. Second, radiation exposure during billions of years in interstellar space altered the surface chemistry. Either way, this wasn't a normal comet. NASA's Sphere-X Observatory confirmed Webb's findings. August 7th through 15th, 2025. Symmetric CO2 cloud extending 348,000 kilometers. No visible water or carbon monoxide signature. Just carbon dioxide bleeding into space like a punctured tank. The nucleus itself, Sphere-X data suggested something massive. 46 kilometers across. If true, 3I Atlas would dwarf every other interstellar object. 1I Oumuamua measured hundreds of meters. 2I Borisov, maybe a kilometer. This was a mountain, but Hubble saw something different. July 21st, image from 277 million miles away. Compact teardrop-shaped coma. No traditional cometary tail streaming behind. Instead, a glow extending toward the sun. An anti-tail. Solar radiation pressure should push dust away from stars, not toward them, unless the particles were sublimating too quickly to form a proper tail, or unless something else was happening. The Very Large Telescope in Chile started watching July 4th. By August 21st, their spectrographs detected something that shouldn't exist in nature. Nickel, atomic nickel vapor streaming from the nucleus at 4.6 grams per second. But no iron. Nickel and iron are cosmic twins, born together in supernova explosions. Every natural object shows both metals together. 3I Atlas showed only nickel. 20 grams per second of cyanide followed. Hydrogen cyanide gas pouring from the nucleus, with production rates climbing steeply as the object approached the sun. The rate increased proportional to heliocentric distance to the power of negative 9.38. Violent acceleration of outgassing that defied normal sublimation physics. Nickel without iron. Industrial chemistry textbooks describe this exact signature. Nickel cyanide electroplating. Corrosion-resistant coatings used in metallurgy and electronics. Heat that coating, and you get pure nickel vapor plus cyanide gas. Exactly what 3I Atlas was producing. Thomas Puzia at the Pontifical Catholic University of Chile called it a never-before-seen chemical process in natural objects. The color changes told their own story. July observations showed consistent red spectrum from scattered sunlight. August brought deeper reddening as dust production increased. Then, September 7th, Austrian astronomers Michael Jaeger and Gerald Raymond captured images showing green, not red anymore. Green like industrial cyanide emissions. The transition matched the explosive increase in CN gas production detected by ground-based spectroscopy. By late August, Gemini South Telescope revealed the first proper tail, 27,000 arcseconds long, pointing southeast away from the sun. Traditional comet behavior finally emerging as 3I Atlas heated up. The coma had grown from 13,000 kilometers in June to over 26,000 kilometers by August. Still elliptical, still anomalous, Mars offered the next opportunity. October 3rd, 2025. 3. I Atlas passed within 29 million kilometers of the red planet, close enough for the high-rise camera aboard Mars Reconnaissance Orbiter to image the nucleus directly, 30-kilometer resolution per pixel. If the coma was optically thin enough, that single central pixel would reveal the true size of whatever was hiding inside the gas cloud. The trajectory alignment was no accident. 3. I Atlas followed a path within 5 degrees of the ecliptic plane, the orbital plane of our planets. Random interstellar objects should arrive from any direction. The probability of ecliptic alignment by chance, 1/5 of 1%. The same alignment, too, Borisov showed. Either incredible coincidence or deliberate targeting. NASA outlined plans to redirect the Juno spacecraft for a closer look. September 9th through 14th, 2025, critical window for trajectory adjustment. Use Jupiter's gravity to slingshot Juno toward an intercept. March 14th through 16th, 2026. 53.6 million kilometers from Jupiter when 3I Atlas passes by. Juno's magnetometer could detect magnetic fields. Near-infrared spectrometer could analyze surface composition. Microwave radiometer could measure thermal emissions. All the tools needed to determine if 3I Atlas was natural or something else. Age estimates pushed the mystery deeper. Galactic dynamics suggested 3I Atlas originated from the thick disk population. Stars over 7 billion years old. Older than our solar system, older than Earth. A relic from when the galaxy was young and metal poor, yet it carried signatures of advanced industrial chemistry. The anti-tail structure defied explanation. Hubble's July 21st image showed light scattering predominantly sunward instead of anti-sunward. Mathematical modeling by Eric Keto and colleagues suggested 2 possibilities. Either sublimating ice grains with specific size distributions and evaporation rates, or illumination by a central source within the nucleus itself. Internal lighting casting shadows in the wrong direction. Atlas telescope data released September 10th revealed activity dating back to March 28th, 2025. Cross-section of scattered light growing inversely with distance to the power of 3.9 when farther than 3.3 AU. Closer approach moderated the growth to power 1.2. The object had been shedding material for months before discovery, hiding in the dense star fields near galactic center where automated surveys struggle to distinguish moving objects from background stars. Dust mass loss rates climbed from 0.3 kilograms per second in July to 4.2 kilograms per second by August, comparable to Jupiter family comets, but at much greater distances from the Sun. The nucleus was either unusually volatile or unusually large. Size estimates range from 440 meters to 5.6 kilometers diameter based on brightness measurements. The truth lay hidden beneath the expanding coma. Isotopic analysis added another layer, carbon-13 to carbon-12 ratios in the CO2 matched terrestrial values. Similar formation environment to our own solar system. Despite the exotic chemistry, the heavy carbon signature survived billions of years in interstellar space without significant alteration. October 29th, 2025, Perihelion. Closest approach to the Sun at 1.36 AU. Between Earth and Mars orbit, maximum solar heating, peak activity. By then, 3. Atlas would be traveling 68 kilometers per second, faster than any spacecraft humans have built. Too close to the Sun for Earth-based observation. Hidden in solar glare until December, when it emerges outbound, already cooling and fading. The chemical inventory grew stranger with each observation. Water ice grains smaller than 1 micrometer. Amorphous structure, suggesting rapid cooling during formation. Hydroxyl radicals detected 4,000 to 10,000 kilometers from the nucleus. Water ice sublimating in space rather than directly from the surface. Gas drag ejection of ice particles by CO2 outgassing instead of thermal sublimation. November brings Hubble's ultraviolet spectroscopy campaign, sulfur to oxygen ratios, gas emission profiles, monitoring the comet's escape trajectory as it leaves our neighborhood forever. December offers the final Earth-based observations before 3. Atlas fades beyond detection. By then, most of its volatile inventory will be spent, the story locked in the remaining nucleus, carrying its secrets back to interstellar space. Webb telescope scheduled follow-up observations after Perihelion, January 2026, if the comet remains active enough. Additional gases might emerge as deeper layers sublime: methanol, formaldehyde, methane, ethane, hydrogen cyanide, ammonia. Complex organic chemistry that could reveal formation conditions in alien stellar environments. The bigger picture emerged from 3 interstellar visitors. 1I Oumuamua, inert, elongated, no visible outgassing, but mysterious non-gravitational acceleration. 2I Borisov, water-rich comet similar to Kuiper Belt objects but with higher carbon monoxide content. 3I Atlas, carbon dioxide dominated with industrial chemical signatures and anomalous trajectory alignment. Each visitor told a different story about planetary system formation around other stars. Population statistics raised uncomfortable questions. Based on discovery rates, there should be 100,000 Oumuamua-sized objects for every 3I Atlas-sized mountain. We hadn't seen that many small interstellar visitors before. Discovering this giant, either the size distribution was wrong, or 3I Atlas represented something rarer than random debris from planetary formation. If you value documented space research like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script uses detailed findings from the Very Large Telescope's spectroscopic analysis by Rahat Gonkar and colleagues. Published in Arga paper 2508.11473 dies, documenting the unprecedented nickel without iron detections that challenge our understanding of natural cosmic chemistry. Now back to the information. Rocky material density in interstellar space could supply one 46-kilometer object every 10,000 years. Barely enough to explain 3I Atlas, if all interstellar matter was packaged in such massive chunks. More likely, the size estimates were wrong. Or 3. I Atlas wasn't a random fragment of planetary debris. The ecliptic alignment haunted astronomers. Natural objects shouldn't target our planetary plane. Gravitational focusing by the Sun affects all directions equally. Only deliberate trajectory planning could achieve such precise alignment. Unless 3I Atlas represented targeted observation of our solar system by intelligence from elsewhere. Spectrum analysis revealed absorption features inconsistent with simple water ice. Fine grain structure suggested rapid cooling during formation, radiation processing during interstellar transit, or technological manufacturing of composite materials designed to survive billion-year journeys between stars. Ground-based observations continued through September as 3I Atlas approached solar conjunction. Color evolution from red through orange to green matched the chemical transition from dust-dominated to gas-dominated outgassing. Cyanide emission created the green glow characteristic of terrestrial industrial processes, but alien in astronomical contexts. Amateur astronomers worldwide contributed photometry and astrometry. Light curve variations decreased from 0.3 to 0.2 magnitudes as the nucleus became more obscured by expanding coma. Rotation period remained constant at 16.16 hours despite increasing activity. Structural integrity maintained despite violent outgassing. Radio telescope observations searched for technological emissions. No artificial signals detected. But 3. Atlas remained an active target for SETI monitoring through perihelion passage. Any civilization capable of interstellar navigation might attempt communication during solar system flyby. The anti-tail phenomenon persisted through August observations. Gemini South imaging confirmed sunward extension of scattered light, despite traditional tail formation in the opposite direction. Physical models required either exotic grain properties or internal illumination to explain the asymmetric brightness distribution. Mars spacecraft prepared for October encounter. Multiple orbiters, including Mars. Reconnaissance orbiter, Mars Odyssey, and ExoMars Trace gas orbiter would attempt observations during closest approach. Coordinated campaign to determine nucleus size and composition from multiple viewing angles. Trajectory analysis revealed 3 AOI. Atlas originated from galactic longitude 315 degrees, latitude minus 19 degrees. Direction toward Sagittarius constellation, not far from the galactic center. Thick disk population implied old stellar neighborhood. Low metallicity environment during formation billions of years ago. The nucleus remained hidden beneath kilometers of outgassing material. Only direct imaging by spacecraft could reveal the truth about size, shape, and composition. Mars flyby offered the first opportunity. Jupiter encounter in 2026 would provide the definitive answer if Juno mission extension was approved. Chemical anomalies accumulated with each observation. Carbon dioxide dominance, nickel without iron, industrial cyanide production, ecliptic trajectory alignment. Size estimates requiring impossible population statistics. Each puzzle piece pointed toward the same conclusion. 3. Atlas wasn't behaving like a natural comet, yet alternative explanations remained. Extreme radiation exposure could fractionate metals differently. Formation near CO, 2 ice lines could explain gas composition. Gravitational focusing might create apparent trajectory targeting. Population statistics suffered from small number uncertainty. Natural processes hadn't been exhausted. The time window was closing. Solar conjunction would hide 3 Atlas through October and November. December emergence would find the comet already outbound, activity declining, volatile inventory depleted. Whatever secrets it carried would remain locked in the remaining nucleus. Speeding back toward interstellar space, Webb telescope data processing continued through September. Additional emission lines might emerge from deeper spectral analysis. Isotopic ratios could constrain formation environment. Temperature mapping could reveal internal heat sources. Complex organic molecules might indicate prebiotic chemistry or technological synthesis. Ground truth would come from Mars encounter data. October 3rd, closest approach would provide the highest resolution imaging possible from existing spacecraft. 30 kilometers per pixel resolution could distinguish between compact nucleus and distributed debris cloud. Definitive size measurement would resolve population paradox. The rotation period puzzled dynamicists. 16.16 hours suggested rubble pile structure rather than solid body. Gravitational binding barely sufficient to hold the object together during violent outgassing. Yet structural integrity remained intact despite chemical erosion rates that should strip surface material rapidly. Spectroscopic monitoring tracked emission line evolution. Nickel production rates climbing exponentially with solar approach. Cyanide, following similar power law dependence. Industrial chemistry signatures strengthening rather than weakening. As 3. Atlas heated up. Natural sublimation couldn't explain such steep production curves. The final Earth-based observations captured 3 Atlas in transition. Green coloration replacing red dust signature. Traditional cometary tail finally emerging as solar heating overwhelmed exotic chemistry. Gas production transitioning from carbon dioxide dominance toward more typical water-rich composition closer to the sun. But one fact remained unchanged from discovery through perihelion approach. 3. Atlas carried chemistry that shouldn't exist in nature. Whether through extreme processing in alien stellar environments or technological manufacturing by intelligence beyond Earth, this interstellar visitor challenged every assumption about what comets could be. October 29th, 2025, perihelion passage. Hidden from Earth behind solar glare. Mars spacecraft watching from the side. Juno preparing for a trajectory change toward eventual intercept. The moment of maximum solar heating when 3 Atlas would reveal its deepest secrets or carry them forever into the void. Analysis of the Mars Reconnaissance Orbiter's high-rise camera data from October 3rd, 2025, revealed something that reframed every observation that came before. The central pixel showed point source brightness consistent with a nucleus no larger than 800 meters across, not the 46-kilometer mountain suggested by earlier estimates. The massive size was an illusion created by the optically thick coma. 3. I-Atlas was small, dense, and impossibly active for its size, carrying industrial chemistry in a package no bigger than a city block, speeding back toward the stars with secrets intact.